This question belongs to algorithm subject and was asked in GATE CSE 2015. So the question states, match the following. We have Prim's algorithm for minimum spanning tree, Floyd-Warshall algorithm for all pair shortest path, merge sort, and Hamiltonian circuit. And list B contains backtracking, greedy method, dynamic programming, and divide and conquer. Let us see all the options one by one. So what is Prim's? Prim's algo is basically used to find the minimum spanning tree. So what is the minimum spanning tree? Suppose we have a graph like this 10. Okay, let us take like this A, B, C and D, and it has edges 10 over here, 20 over here, 30 over here, 40 over here and 50 over here. Then what is a spanning tree? Spanning tree is a subgraph of a graph which is a tree. Tree means it should be acyclic and it should be connected. And if the graph has V vertices and E edges, the tree should have all the V vertices and number of edges should be equal to number of vertex minus 1. Okay, so it will have many spanning trees like A, B, C, D. This 50, 40, 10. This is a spanning tree. We can have other spanning trees like A, B, C, D. 10, 30, 50. But if we have cost associated with each spanning tree, here we have 50 plus 1, 60 plus 40, 100 cost. Here we have 53, 80 plus 1, 90 cost. So minimum spanning tree, in minimum spanning tree we need to find the minimum cost. So for this we have either Prim's algo or Kruskal algo. In Kruskal it is based on finding the minimum edge and combining them. Prim's algo, how Prim's algo works is that we go with any of the vertex. Let us suppose we start with vertex A and then we find the minimum edge among all its adjacents. So among 10, 30, 40 minimum is 10. So we do 10 and B. Now we find minimum among A and B. So A has 40, 30 and 10 and B has 20. So minimum is 20 for D. Now we find minimum among this A, B and D. So minimum is 30 but it is making a cycle. So we neglect it. Now next minimum is 40. So we have 40 as the next minimum. Now this is our spanning tree. So here we are finding minimum at each step. Thus it is based on greedy method. So Prim's is based on greedy method. Let us see second option. So second one is Floyd-Warshall. Floyd-Warshall is basically used to find all pair shortest paths. So if we have certain graph like this, then we need to find what is the shortest path to go from A to B, C, D as well as E, like all pairs, and from E to all A, B, D and C. So it's basically based on dynamic programming method. If you want to learn more about this, you can go to this link and you will get to know the DP solution for Floyd-Warshall algorithm. Okay, let us see option C, it's merge sort. So how merge sort works? Suppose we have 20, 10, 30, 50, 5, 11, 19. So it's based on divide and conquer. So what it does is that it finds the midpoint 1, 2, 3. So here 50 is the midpoint. Okay. Then it divides it into two parts. Here we have 20, 10, 30, 5, 11, 19. Let us suppose 50 comes over here. Again it divides it into two parts till we get a single part. Let us suppose we get here 20, 10, 30, 5, 50, 11, 19. Now it combines it. So here initially it sorts it. It's already sorted. Now while combining, it makes sure that it is sorted. So it combines these two and gets 10, 20, 30. It combines these two and gets 5, 11, 19 and 50. Then it combines these two to get 5, 10, 11, 19, 20, 30, 50. So it's basically based on divide and conquer, DSC based algo. So Floyd-Warshall was DP, merge sort is divide and conquer. Let us see Hamiltonian circuit. So what is a Hamiltonian circuit? So we have been given a graph. So a Hamiltonian path. Let me first show you the graph. If we have some graph like this, C, D, E, like this. Then a Hamiltonian path is a path that traverses all the vertices exactly once. So A, B, C, D, E. It is a Hamiltonian path as each vertex is coming exactly once. Now what is a Hamiltonian circuit? If there is an edge between the starting and ending vertex, we have an edge between E and A. So it becomes a Hamiltonian circuit. So how we go ahead with this? We start with any of the vertex. Let us suppose we start with A, mark it as visited. Now we go to its adjacent. Let us suppose the graph is like this. We have B and D. We go to any of its adjacent. Let us suppose we go to D. Then any of its adjacent. Let us suppose we go to E. Then any of its adjacent. Let us suppose C. Okay. And if in the end we are able to mark all the vertices, which means we have all the 5 vertices, then we have C to B and B to A. If in the end we are able to mark all the vertices and we can end in A, which means we have a edge from B to A, then we are able to do this. But if we are not able to reach at any such point, let us suppose it was something like this, then we go from A to D to C to E, A to D to C to E, and then we can't, all its are visited. Like we can go to A but B is left out. Here we need to do a backtrack to C and then traverse all other options like A to D to C to B. Here now it becomes a Hamiltonian path. Okay, so we need to check for all possibilities. So Hamiltonian circuit is based on backtracking, as we need to backtrack whenever we do not get a possible option. So answer is P is mapped to 2, Q is mapped to 3, R is mapped to 4 and S is mapped to 1. So option C is correct.